All right, everybody. Welcome to today's webinar, Get Comfortable with Container Technology. I'm Jay Martin, your host for the next hour. Certainly, if you have any questions throughout today's presentation, please add them to the Q&A section on the right side of your screen. And our team of experts will do their best to answer each of those questions before the end of the webinar. We are extremely blessed to have a pair of panelists today, including Curtis Reese, a Senior Solutions Architect from Amazon Web Services, and Ben May, one of the fine solutions architects at ClearScale. Before we begin, I'd like to have each of our panelists discuss their roles and their companies, starting with ClearScale's very own Ben May.
Hey all, my name is Ben May. I do pre-sales and project work here at ClearScale. I focus on everything Amazon services. So I'm the guy to talk to for any issues within Amazon.
Excellent. And Curtis, what is this AWS I keep hearing about?
Is AWS. It's the leading cloud provider of cloud computing. And what I do with AWS is I'm a senior solutions architect focused on containers and app modernization. And I had the fun distinction of being the acting tech lead for DevOps for AWS for a period of time. And so it's my job to work with partners like yourselves and customers, be successful implementing modern workloads on containers.
Excellent. Well, today we do have a three-pronged approach to the webinar. We'll start with AWS walking us through the current state of container adoption. Then ClearScale will review some of the most common scenarios utilizing this technology. And finally, we'll review some real-world results exploring ebates, savvymoney, and entropix use of containers. So without further ado, we'll get started. Curtis, if you'd please educate us on container technology and AWS.
Awesome. Well, to get started with the idea of containers, we got to kind of understand what they are. And if any of you have run web applications, you know the process of writing your code and getting it executed on a server and having to spin up VMs to run those servers. And the idea is that can be somewhat heavy. You know, you have the underlying OS, you have your code, the process of getting that run oftentimes is unique to each server. So we'll go through a process where you've got to copy the code out of version control onto a server. And that leads itself to a lot of variation and change. You know, you get into those scenarios where you get it onto a different tier and suddenly something doesn't work and the developers look at you and go, oh, well, that ran on my machine or it ran on dev fine. And containers are really an approach to try and address those challenges. And so they're a way to take the applications and bundle them up into self-contained units of just the application code and the binaries and libraries needed to run those. And because they're these self-contained kind of atomic units, where you run them doesn't really matter. As long as you've got a container runtime like runc or Docker underneath, it could be a Windows host, it could be a Linux host. The size of the host doesn't really matter. It's wherever you deploy that bundle, it's going to run and execute the same. And because they're these nice little tight isolated packages, they run isolated in memory, they run isolated on the network, so they can be completely walled gardens and walled off from each other. And when you actually run those, you can run them with greater density. So if you think about it, if it's just the application code and it's just the binaries needed for that, they can be run on layers of OSs. So if you have like an OS that you need to run, say it's Amazon Machine Linux or Ubuntu or whatever, all of the containers that need that layer, that OS layer, can actually share it. So in a traditional sense of like a VM, you would have, say, a Windows server or a Linux server. And for every instantiation of that application that would need that OS, you'd have to copy that whole OS. And so you imagine to run the one application that can get quite large. It can be in the gigabytes of size. Because these containers can share those layers, if you have, say, 3 or 4 servers in your cluster, the first time you run a container on that server, it downloads that layer, which would be the Ubuntu layer or whatever the OS is, and it runs and copies that container image to that server. It does that the first time. But say you want to scale that out, and suddenly you want to run 50 versions of that container. You don't have to download that OS again. It can use the same layer that was already downloaded. And because of that, you can, instead of having to deal with what could be potentially gigabytes, you can get down into the megabytes. And instantiating additional versions of that container can actually be performed in seconds. So you can go from having one version of the container running to 100 versions of that container running in literal milliseconds. And that's because of the way that they build these layers, and they're self-contained. And you can ensure that when it executes the same, because they're these versioned bits of code that are basically stored in image repositories and shared throughout wherever you need to run them. And because of the way that this scaling happens and the fact that they run in these shared layers, they can be very lightweight, which means you can get them to greater density. So you can get cost optimizations. So instead of having to worry about copying an OS to an underlying server and then the application code and everything that goes along with that, which can take gigabytes of size and take up specific memory that doesn't necessarily relate to the application, now you can get these really whittled down services that are running that only leverage the minimal footprint, which means you can get greater density on your servers. And then using things like AWS's spot instances, you can get pretty cheap servers that can run at greater density, which means you can save a lot of costs. So where you would typically have a larger footprint, you can have a smaller footprint potentially, or you can have a footprint that's now geographically dispersed, because they're going to run the same, and you can deploy them through code to other parts of the world. And so you have a lot of opportunity to run your workload in a much more performant sense, in a much more scalable sense, in a much more repeatable and dependable sense, in a completely network isolated and secure manner, in ways that you probably weren't able to before. And so the long story is, this is the idea behind the container. And so by shifting your application development processes over to this, you can create this flywheel of success where you can listen to what your customers are asking for. You can iterate more quickly. You can test the waters in a much more scalable and cost-effective way, so you can get those features out to your customers as quickly as possible. And this is the idea behind modern app dev and leveraging containers for that. Now let's talk about the state of containers. And the idea here is, how many people are leveraging containers? Well, for most people, containers are becoming the new norm. So it's a kind of a combination between that and serverless. And on containers on AWS, 80% of all containers applications literally run on AWS today. So this is the stat that we want to share. There's multiple ways that you can run your containers. Some of you have probably heard of Kubernetes. We have our own orchestration platform called ECS. Between the two, and including Fargate, 80% of containers are run on AWS, and 56% of Kubernetes clusters are actually run on AWS, whether that be in AWS EKS, which we'll talk about later, or running in self-managed Kubernetes clusters. That's a surprising statistic. So when you think about that out in the world, all of those customers have turned to us because of the things that I said previously: scale, security, the ability to run your workload regionally and globally with ease. And that's something that AWS provides. And so it's enabled all of these customers to come in and run their container workloads on AWS. And there's lots of different ways, like I said, but one of the ways that we kind of want to talk about today is AWS Fargate, which is our serverless container option, where you basically bring your container and we'll bring the server and the execution. So you don't have to worry about managing the underlying clusters. You don't have to worry about OS updates, that kind of stuff. Like, you just bring your workload and we will run that workload for you. And we're seeing hundreds of millions of task executions for Fargate every week. And that continues to grow as we continue to see more and more customers adopt serverless and containers and app modernization. And along those lines, we're seeing a 10x year-over-year growth within AWS container services. And we're continuing to advertise our roadmap and share that out with customers. So if any of you want, I can share the link to the AWS roadmap, but you can actually look that up online. It's in GitHub, and you can actually participate in that roadmap. So you can see where we're headed with our container services and the features that we're trying to reach all of you with on a daily basis. And you can +1 the things that you think you need, or you can even participate to say, hey, wouldn't it be great if we had X? And the service teams here are actually listening to those feedbacks, because we're a customer-focused company, and we appreciate the feedback that you guys provide. And pretty much 90 some odd % of all the features that we release are because customers ask for it. and as you run your container workloads, we like I mentioned, containers are essentially code, and they're stored in version repositories. And we have a version repository for container images called ECR. And what we're seeing is that, along with Docker Hub and other registries out there, we're seeing 2 billion images pulled using just ECR alone. And so every week we're seeing that kind of execution, to show that customers are leveraging AWS, and they're storing their images for their workloads within ECR for ease and security and performance. So there's lots of opportunities for you to see that success for your own workloads. Um, but a lot of customers, when we talk to them, there are concerns. Anytime you move to a new technology or you try and adapt or adopt, there's risk. And what we want to showcase is that there are ways to mitigate risks. And containers themselves are an attempt to mitigate risks. Like I said, we want to make sure that the containers run quickly and efficiently. They run consistently. Um, they're set up so that you can go through and do unit testing and performance testing on them with greater ease. But when you execute them on AWS, we want you to know that you can also take advantage of the security footprint, and the capabilities that AWS provides. And so with regard to container security, we offer 210 security, compliance, and governance services. Um, which is about 40 more than the next largest cloud provider. But the idea is, what you can do from a security standpoint on AWS is probably greater than what you could do by yourself. And the fact that if we have a large customer that comes along and needs something from a security perspective, doesn't matter the size of your company, you actually get to benefit from that. So if we implement something that's new in the container space that's secure, or features some capability that lets you isolate your workloads a little bit better, or we offer an integration with a third-party vendor that you leverage, these are all opportunities that are immediately available for you to benefit, whether you had a security team or not. We offer a global footprint, and we provide 2 times more regions with multiple availability zones. And just so we're clear on what an availability zone is, these are essentially, think of them as data centers within a region, and they're geographically dispersed. So as you spin up your applications and try and run your workloads in a specific region, you've got the option to spread those workloads out and distribute them within that region for availability. So say a data center goes down, you got your workloads spread across multiple data centers within that region, and you aren't affected. You have high availability, and redundancy there. And with AWS, we've got well over 100 services now, and that continues to grow year over year. We're constantly releasing new features. As you spin up your workloads, those features and capabilities are there available for you to take advantage of. And in the container space, it doesn't matter whether you're using Fargate or ECS or even EKS. If you need a database, or you need machine learning, or you need some IoT integration, or you want to run a key value store, or you want you want to leverage some kind of high available database, or go completely serverless in your config, we offer services that allow that to be flexible, and you can take advantage of within your applications with relative ease. You've heard me mention it a couple times now, but we want to call out AWS Fargate. This is kind of our lead-in these days. Um, when we look at what customers are trying to do with their application workloads, we want to shift them out of having to do the undifferentiated heavy lifting. So managing the underlying server instances, having to turn the dials and the knobs, and try and keep up to date with security patches and OS updates and all the other stuff that goes along with running a server environment that isn't necessarily part of running your application. It just kind of comes along for the ride. And so if we can get that off of your plate and enable you to focus on just running your application and the features in your application, we're setting you as a customer up for success. We're allowing you to focus on focusing your resources on the things that matter and are actually driving your business and helping you reach your customers with greater ease. Fargate is kind of our approach to that, where instead of having to run clusters for Kubernetes or even for ECS, we will bring the cluster on your behalf. And so when you want to run a new version of your container, instantiate a new pod, we will actually go up and spin up a host, attach it to your network, protect it in kind of a walled garden kind of setup, but then run your container on that for you. And this allows you to scale out infinitely without having to worry about how many clusters are in your hosts, or how many hosts are in your cluster. And it allows you to scale from ones to hundreds of containers with ease. And none of that requires you to do any management of the underlying host. You basically develop your code, build your container image, store it in a repository, and then say, what are the requirements for executing it on AWS? And Fargate is a very easy way to get started, both from a development standpoint. It's easy to get started from a scaling standpoint. And so it doesn't matter whether you're net new to containers, it's a great way to begin. But if you're even mature with containers, it's a great way to scale and meet the needs of your customers and ensure high availability. And these work with both Kubernetes and our own container orchestrator, ECS. And they're essentially treated as a compute layer. So it's not a service in itself, so to speak, but it's more of a compute layer for those two services. So you can choose to run your own nodes. You can choose to run Fargate nodes within them. You can run them in a heterogeneous mode where you've got some that are Fargate, some that are self-managed, so that you can find even optimizations of costs. Or say you want to run really cheap clusters with Spot Fleet, which is our marketplace where you basically set your price for spot. And you can scale out that way. But if you also want burstable workloads, you can scale out with Fargate. You can combine these with what we call reserved instances, which is when you prepay for a portion of your workload to kind of provision it and keep it in your account. You can find a cost optimization scenario with Fargate that works for your workload and works for your budget. It's really a nice model to kind of start with and grow with. And then in addition to that, there's an entire ecosystem of services that we offer for storing your images and exposing those to the various clusters that need to execute your workloads. We've got ECR, and it's a fully managed Docker container registry. You don't have to necessarily use ECR, but it's what we provide. We work with basically every other registry that's out there. So if you've got one, say you're using Docker Hub today, that's fine, but we want to provide at least the base capability for you. This is highly scalable, and it makes it available within your environment. So if you don't want to pull things out from a third-party vendor, you can pull it directly from within your account, essentially. We offer Amazon Elastic Kubernetes Service, or EKS, which is our native upstream version of managed Kubernetes. So we'll manage the control plane for you. We will even manage nodes for you, or you can operate in a fully managed state using AWS Fargate. It allows you to spin up the latest version of that we support of Kubernetes, and trust that it's Kubernetes. It's not something that we've changed. It's not the AWS version of it. It is native Kubernetes. And so if you're running 1.16, all of the features and capabilities that came with 1.16 should work. All of the ISV or third-party solutions that work with 1.16 will work. And it integrates with service meshes like AWS App Mesh or Envoy or Istio. So you can build these highly scalable Kubernetes environments on AWS with that, or you can leverage our compute layer underneath, which is AWS Fargate or EC2. So you can run your own servers, or you can let us run them for you. And you can basically isolate them, manage them, and then right size them based on the right mix of your needs.
Excellent. Well, that was a great overview on containers and the current use and utilization. So appreciate that, Curtis. That brings us to our first poll question of the day. And that is your company currently utilizing or considering utilizing container technology? So we'll give just a brief moment for some answers to roll in, and that will certainly help shape, I think, the direction that Ben will take us next. Excellent. Well, as these results are pouring in, certainly looks like a lot of people are either exploring the use of containers or have actually implemented some already. But it's always good to have a few people here that this is their first introduction to containers. So certainly if you need more information or would like to talk to Ben afterwards, we can help align those solutions architect calls, and you can get a lot of your answers from there. But let's move forward. And again, if you have any other questions, you can submit them in the Q&A section on the right side of the screen at any time, and we'll cover those at the very end. Now that we have an understanding of the current state of containers, Ben, if you would please walk us through some of the common use cases.
Yeah. Great. Thanks, Curtis and Jay. So I'm going to talk about first the appeal of containers. Curtis already went through a lot of this, and it seems like some of the audience here is already using containers. So you might know some of it, but containers eliminate basically the overhead of running an entire virtual machine in order to run an instance of your application. This high efficiency gives you the ability to have many more instances of an application running on a single piece of hardware. So this really makes containers ideal for running microservices architectures or batch jobs or things like that. Containers also make your development process more smooth by allowing your developers to have an exact copy of the production image to test against. So Curtis went through that, and they use ECR and Amazon. But basically, the same image that you're using in production, you could pass down the line, and your developers could test against that image, which makes development really smooth and a lot less of the "it works on my machine" type of thing that happens. And if you're familiar with Vagrant, Docker makes this process similar, but it's even easier. So you really do have an exact image. And while the cloud is not required to run containers, using AWS makes the process of running the production container systems much easier with the AWS managed service offerings that Curtis mentioned, like Fargate, ECS, and EKS. Amazon manages a ton of that, and they make it a lot easier for your team to not worry about that infrastructure. So right now, the use of containers is still going up, though. So the International Data Corporation forecasts that there will be over 1.8 billion enterprise container instances deployed in 2021, with 85% of new adopters deploying containers into production. So before, containers were kind of an idea, and it was like something that people were interested in. But now it's in production, and very large systems are using containers now. And as Curtis mentioned, a lot of them are in AWS. So let's talk about like some of the examples. My first example is microservices. Microservices are becoming more popular. If designed correctly, they can increase your time to market with a streamlined development flow, quicker regression testing, and easier deployment methods. Using microservices with containers allows you to break up your application more and use other tools within AWS. So for example, you can allow focus on the backend, or you can allow your team to use like AWS Lambda or API Gateway to be the front end of your application and push authentication through like Amazon serverless products like Cognito, and then let your developers focus on the backend. So if you have a large development team, you could then spread your team between specific services or product offerings, or tie your development team to sales groups so that you could hit the market a lot faster than before. These types of software architectures create a better integration and force better documentation of your actual application. So the next example is application migration. And with containers, you could essentially package your old applications and ship them to the cloud, or run them on site, and take advantage of a lot of the container pros that Curtis mentioned. So this will allow you to take advantage of fast cloud network infrastructures and global reach with many of the different deployment regions also. So if your application is stateless, you could easily scale your application horizontally and take advantage of high availability. You would define how much CPU and RAM your application would require in AWS, and AWS would take your application configurations and deploy them. And then using AWS Fargate, you never even have to like see the underlying hardware. Amazon will run that and manage that all completely for you. And if there's any outages, it'll be shifted over to another instance. And then if your container needs more resources, you could set up guidelines that AWS will follow to create more instances of your applications as you need to scale. So we talked about containers and Kubernetes, but really Kubernetes is its own beast, and some teams are already using it. So if you're familiar with like kubectl, you could use it directly with AWS EKS. So as Curtis mentioned, like you're still running Kubernetes in the cloud. Amazon's just managing a lot of that for you. So you could take it so you can manage your workloads in a hybrid mode or all in AWS. And this is really great for this example, batch processing. So for example, you could have your production workload running on site with a set amount of hardware, but you need to run analytics without affecting your existing workload. You could easily outsource that job to AWS machines where the heavy lifting can be done. And then if your job is not mission critical, you could even set up spot instances, like Curtis mentioned also. And that means that you're basically renting these servers at a discount during non-peak times or when they're not in use, which saves a lot of cost for a lot of customers. Then my last example is machine learning. And machine learning is really becoming the new norm because machine learning usually helps your product be more competitive or even allows your company to take advantage of new niches in your market. And this means that getting to market fast is really crucial. So luckily, like you don't want to like have to rack and stack and set up images to get your machine learning team going. Amazon has GPU instances with deep learning containers already ready. So these are basically containers with pre-built images with ML frameworks like TensorFlow and PyChart. And you could spin them up at a click of a button, and they're already ready and optimized to take advantage of the GPU.
All right. Well, thank you very much for that overview of a handful of services there, Ben. That does bring us to our next poll question. Has your company explored the use of machine learning? Certainly it's a growing piece, but our 4 answers there are: we have implemented machine learning, we are exploring the use, we have not discussed using machine learning, and we're not interested in using machine learning. So we'll let the answers kind of roll in, and then we will continue on as we look at some real world examples. All right. It looks like the early results showcase that a lot of people are exploring the use of machine learning or haven't discussed it yet, but they're still open to that conversation. So again, certainly if you are looking to get some of your questions answered by Ben or Curtis, please add them to the Q&A section on the right side. And we'll be more than happy to answer anything related to containers or even machine learning on that standpoint. So we've heard about the current state of containers. We've heard about common use cases, but where are those real world applications? Well, let's take a look at a few specific examples currently being implemented, starting with ebates and their need for elasticity.
Great. So ebates is like an online cashback website. They work with major retailers like Best Buy and Verizon and even Amazon to help its members get cash back on online purchases. So they have over 1 billion users using their system with over $1 billion in cash back. So it's a pretty large system, and they've grown a lot over the years. So they're initially hosting all of their infrastructure on site, and they're growing like way too fast to keep up with it. They were trying to rack and stack as fast as they could during the holiday seasons, but then afterwards they were stuck with all this extra hardware. So it was really bad for their procurement and also their budget going into the next year. So they really needed the ability to scale quicker than what they were able to do on site, and they kind of knew they were going to be reaching or going towards the cloud. So they reached out to ClearScale to say, hey, how can we move this on site and make it really flexible and save some costs while we're at it? So we reviewed their system and designed a cloud infrastructure using Kubernetes. And we were essentially able to migrate their existing application and build a CI/CD pipeline around that. So after we did this whole migration and built this all out, they were able to take advantage of auto scaling in Amazon. So now instead of running at their peak load like they were doing before, they're able to run at the load that they're basically using at the moment, so within minutes instead of for the season. So it was really good for them in cost savings. They had a 60% cost savings, which is great, and a lot of customers see a ton of cost savings when they are able to implement auto scaling in their systems. So with this, we built this whole CI/CD pipeline, and we were able to improve their deployment cycle to deploy in 50% less time than it took before. So now their company was focused on the parts of their company that increase their value and not their IT infrastructure. So the next example is savvymoney. So this is a company that we work closely with. We help develop with them and get their product to market. And so they provide an integrated credit score and personal finance solution for online and mobile banking platforms. And like ebates, savvymoney needed a way to scale and deploy quickly. They have a competitive market, and they needed to be able to get out products to their customers and test products very quickly, and do sort of canary style deployments to know which products were working with their customers. So we needed to reinvent their deployment pipeline, but we also had to refresh their entire application architecture. So us at ClearScale, we redeployed their application using the Elastic Container Service. And then we decoupled their application to take advantage of microservices architecture. So now we're using other services within Amazon that are managed by Amazon and are kept secure and updated by Amazon. So we don't have to worry about that. savvymoney is handing that responsibility over to Amazon. So now their product team can deliver products in a much shorter cycle, and they have a stable and scalable system for all of their customers. And then last is entropix. They're a computer vision software company. Really cool software. They basically track different parts of your, basically anything a human would see. They would see that through their system and be able to provide results either for tracking or for recognizing images, things like that. A lot of this runs on GPUs, which is really heavy, and it's hard to rack and stack that. So they were building a multi-tenancy SaaS solution on Amazon, and they reached out to ClearScale to help them build the solution. So we had a couple areas we needed to focus on. First, we had to refactor the major layers of their application into like elastic auto-scaling groups so that we could scale based on a queue. We had to transition their block storage, EBS, into an object storage, Amazon S3, so that would also allow us to scale. And then lastly, we had to transition their current database to Aurora Postgres. And Aurora has the ability to spin out a lot of read instances so that we could essentially scale now the database horizontally with load. So we broke up all of their application and started deploying it with AWS ECS again. And ECS allowed us to take advantage of the GPU that's running on the instances in the Amazon data centers. So this was necessary for the entropix software to actually run. And it made it where they could essentially run at full capacity on one or two machines instead of running many machines using the containers like this. So the auto-scaling system can also base the amount of instances running on the customer-defined queue. So this meant that there was enough compute capacity needed for all of their customers. So now we've moved this system from sort of a POC stage to a full SaaS offering, and entropix was now able to sell their SaaS offering with like an enterprise-grade system. So at ClearScale, we do a lot of different projects with containers, and these are just some of our container offerings. So we do a proof of concept. So if you have an existing application, in 4 weeks, we'll build out that POC infrastructure and the environment so that you could see your application running, and then we'll package that into a container and kind of give you the idea of how containers are running in the cloud and get your team familiar with that. Then the second one is container infrastructure build. So we'll gather requirements and design architectures. This takes a little bit longer, but we'll do a full automation as code deployment of your infrastructure. And then we'll deploy your containers you have on site in the cloud in a production environment. And then last is container CI/CD. This is 2 to 4 weeks, and it's usually coming in and looking at the containers, how your development system uses it, and then building out a complete development pipeline and flow, continuous integration pipeline, so that you can deploy your containers quicker and get your products to market faster with easier testing.
Again, thank you for the overview there, Ben, of some of the customers that ClearScale's had. And certainly if you're looking for case studies or any more information on some of these customers, you can find those all on the ClearScale website. And you can narrow also by not only the type of service like containers, but you can also narrow by the industry as well. So if you're looking for a specific use case. That brings us to a handful of questions that have kind of rolled in. And so we're going to start with our first one for Curtis. How does someone choose between EKS and ECS?
That's a very common question. And the reality is it really depends upon the team. So when we look at it shifting to more of a modern app dev approach with containers and serverless, it's more than the technology, it's also the processes. And what we find is that many customers have already adopted Kubernetes and have built processes around that. So they have mature CI/CD processes, or they've implemented at least base level CI/CD processes. And in that sense, we don't want you to have to change those processes. We want to streamline them. So for those that are built around Kubernetes, by all means, continue to leverage EKS as your cloud option for your Kubernetes workloads. And that way, it just kind of plugs in, and you're really not affecting the team or your productivity in that sense. If your team hasn't already adopted Kubernetes and say they already leverage other AWS services, or they have processes around managing AWS infrastructure through things like CloudFormation or Terraform, they're already leveraging other services. ECS is kind of a logical tie-in there because it's going to follow the same paradigms. And so if you look at the two, one is built with a very AWS-centric paradigm where it uses IAM policies on each task. It uses VPCs, and it's very just native throughout. Like you can still access it through the console as well. When you look at EKS, we've limited the AWS side of it to just the infrastructure side. Spinning up your cluster, maintaining the specific version of Kubernetes on it, like the CLI for it and everything is really around just, have you spun up the cluster? Have you updated the cluster? Give me info about the cluster and delete the cluster. Everything else you do beyond that is really Kubernetes and from the Kubernetes worldview. Like even connecting to AWS services, we offer the operator for EKS, which lets you use YAML files and kind of Kubernetes constructs to instantiate AWS services. And so when you think about that, like if you've already got a Kubernetes setup, stick with that. If you've got a real AWS setup that's more native, go with ECS. Both are going to give you the opportunity to scale. Both of them are going to tie into pretty much any CI/CD pipeline you have. Both are going to be performant and secure, but they've each got their own little trade-offs on, like, does this operate with Helm? Well, that's going to be Kubernetes all day. And so it's just a matter of what tools and what processes your team have set up. And then if they haven't really done anything with containers, I would argue start with Fargate as much as possible, so that you're not managing the underlying infrastructure. You're just really bringing the workload. I would say long term, the way that I would look at being a developer is I want to get as left in that process as possible, or out of managing infrastructure and focusing on just the code, where my configuration kind of says where it needs to be executed, whether that be on ECS or EKS or a Kubernetes cluster by itself or wherever. Hopefully that answers the question. But it's really just a matter of what's right for you and your team. Like all will work for you.
Ben, did you have any additional comments on that?
No, I think that's great. I usually lean towards ECS unless there's a reason to use EKS, and then Fargate all the way. We use it a ton at ClearScale, and we love Fargate.
Yeah, I think a lot of it is if you've already got infrastructure and you've got, say ISV solutions like Datadog and others already spun up and provisioned, it's just another service within AWS to add to that. If you've already got Kubernetes, you're going to follow those things that way. So it just kind of as a tie-in that way. So it makes it kind of easy and more seamless if you just kind of go with what maps to your processes that day. I will say that Kubernetes is evolving very quickly, and we're constantly seeing a lot of focus and attention on it. But in that, there's a lot of churn still. ECS has been around for a while. It's very stable, and we have found that customers that get to extreme scale have gone back to ECS because it can achieve that extreme scale with less effort. Like there's less knobs and stuff that you have to turn. So it can be more easy if you have to run, say, 1,000 to 5,000 nodes in your cluster. It can be very easy to spin that up with ECS and get more performance out of it. So, but those are like extreme edge cases. For the most part, it's both will work for you. So figure out what's going to work for your team and help you reach your customers faster.
Perfect. Another question, can you talk about the role of serverless computing along with containers? And Curtis, will again start with you.
Say that one more time.
Talk about the role of serverless computing along with container.
So what I would say is if you're building an application, more often than not, it's not just going to be containers. You're going to need additional services. You're going to need a NoSQL database. You're going to need, probably some kind of message queue, some kind of event processing. And so if you think about your application holistically in that context, maybe the backend is going to be some long-running process that might run exceptionally well in a container. But maybe front-end requests don't necessarily need to be long-running. Maybe those would be better off as lambdas behind an API gateway. And as they execute and make requests, the long-running processes in the background can be executed by Fargate containers or containers running in EKS or ECS. What we find is that when you look at it in that mode, you can find the right tool that's for the job based on what that job might actually be. Whether that be a message queue with SQS, sending notifications with SNS, running serverless functions with Lambda that then interact with kind of a queue processor that's running in containers, whether that be batch. What you find is that if you go the serverless route, you might see a good combination of all of those that can reduce the footprint that you have as far as the servers you need to run, can help reduce your cost. I wouldn't say it necessarily reduces your management, but it simplifies the type of management tasks that you have to do. It puts more focus on monitoring and security than just keeping servers up and running. So it's still providing you, like, the management layer there provides you with more context about what's going on in your applications and the upstream and downstream dependencies. So it's putting more focus for your development teams on the things that are really important to them and they should be focused on. And reducing a lot of the other stuff that they may not actually be interested in or need. So I think that's where I would look is you're building serverless applications. Like, what's the right mix of containers and Fargate or Lambda and Fargate and managed services? Ben, what do you think?
Yeah, I think that's a great response to it. I also want to just kind of point out that serverless doesn't have to be this completely decoupled microservices architecture.
Mm-hmm.
If you look at an application stack, you have front end, back end, and then a database, or middle and a database. And within Amazon, like, you could run a lot of your node applications just in S3, and we overlook it, but S3, CloudFront, those are serverless offerings.
Yep.
Now in the back end, we have Aurora serverless, which we use at ClearScale a lot, which you have MySQL and Postgres. So it's a great tool. It doesn't necessarily go into running that microservices that you wanted, but for serverless, you're running as little as you can in your containers, and then relying on Amazon to run those other parts and manage those other parts. This is also great for your development pipeline, because you could spin up many versions of an application or break off a branch and spin that up and test it or demo with customers, and you don't have to pay for that whole instance or whatever it be. So there's different things like that. So it's not one way. There's many of ways to take advantage of serverless in Amazon, and with containers, it works out a lot of times.
Yeah, that really hits the point of, like, finding the right task for the job. And it leads me back to a common challenge I see with customers that are shifting to containers. Oftentimes when you adopt a new technology and specifically containers, there's this mindset of everything needs to be a container. And that's really not the case. And so if you're making that transition over to containers, it's really finding what needs to be run in the container versus what you can offload to a managed service versus what you can offload to other things. And so, like, that question about, should I run a database in a container? And there might be scenarios where that is the case and there's a legitimate need, but I would treat those as like edge cases where, if you run a database in a container, you're still having to manage a server in that sense. Like that instance is an instance of a database running. Where if you used a managed service like DynamoDB or Amazon RDS, you don't have to worry about that. Like, you get a database and your app can connect to it, but you aren't now in the business of managing that database. And so really trying to understand what needs to be containerized versus what you can take advantage of a managed service for, like S3 or DynamoDB or something along those lines.
Perfect. Well, should any of the attendees have any questions, please feel free to schedule a consultation with one of our solutions architects by simply reaching out to sales@clearscale.net. I want to thank AWS and ClearScale's very own Ben May for participating today. And then finally, please be on the lookout for some of the upcoming August webinars, including best practices for managing and analyzing your data with AWS, migrations going the distance without disorder, and then processing streaming events at scale with Amazon Kinesis and AWS Glue. And then we've got more to come even beyond those. So certainly subscribe to kind of that Big Marker channel and flag all those webinar emails I'm probably sending to your emails on a regular basis. Emails will be coming out soon for each of those webinars. So please kind of keep track of those, and we'd love to see you attend. Otherwise, please have a great rest of your week, and we look forward to discussing containers with you soon. Thank you again for your time.
Thanks, everyone.
Thanks all.